Hi, I am Arib. You are watching my YouTube channel. Battery bank. In science and technology, battery is a device that stores chemical energy and makes it available in an electrical form. Batteries are a collection of one or more cells whose chemical reactions create a flow of electrons in a circuit. All batteries are made up of three basic components: an anode, the minus side, a cathode, the plus side, and some kind of electrolyte, a substance that chemically reacts with the anode and cathode. DC supply. DC distribution is used in a substation to power substation control equipment such as the switch gear, tap changers, relay, and control system. These equipment run on DC power and thus they need a DC power to operate. The reason is that there will be lesser losses over the inductive reactance of the motor coil and relay coils when DC power supply is given, and it will also reduce the complexity of the circuit, thus resulting in lesser chance for faults to occur. Moreover, the use of smart system and control further increase the need for DC power. Besides, in case of a fault in the substation, the power supply can be given to the equipment very easily by direct connection to a 220-volt battery bank. The DC distribution panel takes the incoming AC power and converts it into 220-volt DC to run the equipment and simultaneously recharge the battery bank. There are generally 55 cells of 2V DC each. There are lead-acid batteries having specific gravity of 1220 and are of 150 ampere. Telecom and wireless network typically operate on 48 voltage DC power. But unlike traditional 12 voltage and 24 voltage system, DC voltage level can be 24 voltage, 48 voltage, 110 voltage and 220 voltage DC. Types of battery used in substation. Lead-acid battery used in vehicles, alarm systems and uninterrupted power supplies. The major advantage of this chemistry is its low cost. Lithium-ion battery used in laptops, modern camera phones, most other portable rechargeable digital equipment. This relatively modern battery type has a very high energy mass. Lithium-ion polymer battery, similar characteristics to lithium-ion but with slightly less energy mass. This battery type can be shaped according to need. Nickel-cadmium battery, used in many domestic applications but being superseded by Li-ion and NiMH types. Rating of battery cell. The electrochemical cells are rated in terms of voltage and ampere-hour capacity. The ampere-hour capacity represents the number of ampere-hours that can be delivered under specified condition of temperature, rate of discharge, and the final voltage. Ampere-hours is equal to ampere x hours. By series connection of N cells, voltage will be NV and ampere-hours. Float-cum-boost charging. Float and boost are the type of charging procedure of battery. Generally, by using float charging we provide the supply to the DC load, and using boost charging we charge the battery, thus we get voltage at battery bus. We use float and float-cum-boost charger. There are two different charger, working principle same. One is used only for float charging and the other one is remained in off position. Obviously, in float charging output voltage will be lower than boost charging but current is higher than boost charging. There is a DC contactor between float and boost charger. During only float charging the DC contactor is open so that interlock between float and boost charger is open and no voltage appears at boost mode. That implies there will be no voltage at the battery bus. The float charging is done by a specific way. There is a control card or AVR card which compares the float voltage with a reference voltage provided through DCPS. Basically, float charging means we provide DC source to the various kind of DC load used in power plant, DC is the heart of power plant. Float charging is never off. To run a plant, if DC source is made off, then the plant will get collapse. So now the boost charger is off. Charging is done in float mode, but we need to charge the battery bus also, otherwise auxiliary DCPS of a plant will be off. To build the voltage up on the battery bus, boost charging is done. During boost charging, float charging is kept off so that the DC contactor should be on, but a very few seconds is needed to make it on. In this few seconds, no power is supplied to the DC load. That means at power plant DCPS is 0 for that amount of time, which is very much dangerous. So to avoid that problem, we have used a tap cell connection. This tap cell 80% of the boost voltage which is supplied to the load in that very short period of time after making the DC contactor on, then battery is charging as well as float charging is also done. This interlocking is used in float cum boost charging. Now somehow the boost charging is off due to fault, then float charging is remain on, and that time the DC contactor is made on, the batteries will be charged in trickle charging mode even after the battery is fully charged, then also they are charging in trickle mode. BMS is installed there to monitor the temperature and voltage across the each cell. Float charging method. In the float charging method, a constant voltage set to a value just sufficient to finish the battery charge or to maintain the full charge is applied to the battery. Typical float charging voltage values range from about 2.15 volt to 2.3 volt per battery cell. The float charging method is commonly used to maintain the charge of lead-acid batteries used in stationary applications, such as in uninterruptible power supplies and SLI batteries, when the battery is charged from the motor alternator. Rectifier. A rectifier is an instrument circuit that changes AC into DC. The grid station. It is used for several purposes. In charges batteries, provide DC supply to the load, shares load with battery during overload condition. The rectifier used in grid has a voltmeter and an ammeter for incoming AC and another voltmeter and ammeter for outgoing DC. Batteries have the following components. Container jar. It is generally made of plastic and gives support to the electrolyte and plates. Electrolyte. A solution of 35% sulfuric acid, H2SO4, and water, H2O, is filled in the container. Plates. Two dissimilar plates are dipped in the electrolyte. One made of lead oxide act as cathode and other made of lead act as made. Connection leads. The electrodes are connected with the connection leads. Vent cap. Every battery have a vent cap that is used to evolve any gas bubbles produced during condition in electrolyte. The 220-volt battery bank in the substation is recharged by the float cum boost charger FCBC unit, and the equipment is powered using DC power. In case of a power failure or any fault in the substation, it is very easy to transfer the equipment onto the DC power supply from the battery bank and let normal operation continue without any problem till the fault is rectified.